All right, so this is page 47 in the workbook. So if you didn't understand or if you were absent, I'm going to talk through it. So this first part up here is just talking about, it's sort of just to get you aware of what the coefficients mean or the big numbers mean. So we're going to be working with this equation up here. So we have 3 coppers plus 8 nitric acids plus 3 copper nitrates plus 2 nitrogen monoxides plus 4 waters. And so it's just talking about 3 particles of copper react with 8 particles of nitric acid, and then that would give us 3 particles, 2 particles, and 4 particles for those. And then atoms, moles, and then just talking about a little bit more, some examples of that. What we really care about when it comes to coefficients is that they represent the ratio of the moles as one thing compared to another thing. So the first, this little bit of practice is just looking at the coefficients and then figuring out the ratio. So if we have copper to, nitrogen monoxide. So we have copper up here and there are 3, and then we have nitrogen monoxide and we have 2, so then it's a 3:2 ratio. And then HNO3 to CuNO3 2. So HNO3 is 8 and CuNO3 2 is 3, so it's 8:3. And then it is 3:4, and then we have 4:2, and then we can reduce that to a 2:1. And then we have 3:4 ratio, and then a 2:8 ratio. We could minimize that to 1:4. And then we have a 3:2 ratio. So you're just looking at the coefficients and then comparing them to each other. So hopefully that's pretty easy. And then we'll do these one by one. So I'll try to get this out of the way. Alrighty. So if we have here, we're going to use this equation right here. So we have 1, we have 3, we have 5, we have 3, we have 5, and we have 2. So we're just looking at the coefficients and how we can compare them. So it says the number of moles of SiO2, so if we have this one right here, so the number of moles of this to produce 10 moles of CO. So we have 10 moles of CO. So if we want 10 and we start with 5, that's times 2. So it would be, then we take our 3 here and multiply by 2, and so then we get 6. Number of moles of CaPO4 2, and so I have 1 here, and then I have 10 moles, so then I have 5 times 2 is 10, and so then I would take 1 times 2 is 2. So it would be 2 moles, and then this next one. So how many would we need? If we have 10 moles of Ca3PO4 times 2. So if we have, or calcium phosphate, so if we have 10 here, and then we need to figure out how many here. So this is for every one of these, we have 3 of these. So if we have 10 of these, then we have 30 of these. And then on the next one, we would have 7 moles here, and there's a 3 coefficient. And then we would have how many of these? And this is a 3 coefficient. So if it's 3:3, that's a 1:1. So if I have 7 of these, then I have 7 of these. Now the next one gets a little bit tricky. So we have to use a little bit more with our ratios. So we're down to here. And so if we have 7 moles of SiO2, so SiO2, we have 7 moles up here. Let me write that down. And then it asks about carbon. So we're going to go from here to here for our calculation. So if I have 7 of this and I need to figure out how many of this, there's 3 of these for every 5 of these. So the way that I remember is this number will be bigger here when we're talking about moles because 5 is bigger than 3. So I know that I'm going to multiply by 5/3. And so then I go down here and I take my 7 and I multiply by 5/3, and that gives me 11.67 moles. And so then the next one says the number of moles of carbon monoxide. So we are here. And then if we have 3 moles of this, so this is an easy one. So if I have 3 of this, then I have 5 of this. So if I have a 3 to 5 ratio and I have 3 here, then it's going to be 5. So that was actually really, really easy. So we're down here at the bottom. So that's page 47.